It began with a flicker, a half-second flash in the telescope array. Too sharp, too fast, too bright. The system flagged it as an error, a sensor ghost, cosmic dust, something forgettable. But a junior astronomer, staring at the raw data feed, hesitated. The pattern didn't fit any known comet, asteroid, or satellite reflection. No thermal spike, no tail, no rotation that made sense. And yet, whatever it was accelerating. Within hours, the observatory team realized this wasn't a system error. Something had entered the solar system, and it didn't behave like anything built by nature. They recalibrated, ran the analysis again. Each time, the same impossible result. An object, thin, metallic, and tumbling. Moving at 26 kilometers per second, and not orbiting the sun, but passing through. For the first time in history, we had detected something not from here. An interstellar visitor, entering our system from the void between stars. They called it Oumuamua, a messenger from afar arriving first. Its shape, elongated, 10 times longer than it was wide. Its spin, chaotic, like a shard of glass tumbling through water. And its behavior, impossible to explain with gravity alone. After rounding the sun, it sped up. No tail, no outgassing, no visible jets, just acceleration, as if something had fired. Was it sunlight pressure or propulsion? A malfunctioning fragment or a probe decelerating into silence? For weeks, NASA's instruments tracked the signal. Then, abruptly, the data stopped. The raw light curves were reclassified. Public updates grew sparse. And what had begun as a scientific wonder slipped into quiet uncertainty. What if it wasn't just passing by? Because if Oumuamua was artificial, even partially, it means someone or something was close enough to send it. And someone else might not have wanted us to know. It was just past midnight on October 19th. Above the clouds of Maui, the Pan-STARRS telescope array swept its arc across the stars, hunting for near-Earth asteroids, as it did every night. But that night, something unfamiliar appeared. A single streak of light, short, faint, moving too fast. The astronomer on duty stared at the data feed. Normally, by the time a frame refreshes, an asteroid's position can be plotted. This one jumped. He logged the coordinates, ran the orbit model, and frowned. The trajectory didn't close. It wasn't orbiting anything. Minutes later, other observatories joined in. Haleakala to Mauna Kea, then Kitt Peak, then Canary Islands, each confirmed the same impossible path. An object entering our solar system from outside it. Within 48 hours, the data reached NASA's Center for Near-Earth Object Studies. The calculations were checked, rechecked, then rechecked again. The object was interstellar, the first ever detected. It had crossed the orbital plane of Earth weeks earlier, already on its way out. By the time we noticed, it was leaving. Scientists scrambled to capture whatever fragments of information they could. Spectra, light curves, Doppler shifts. Every photon mattered, because we'd never seen anything like it before. No one could agree on what to call it. Asteroid, comet, probe. Finally, a name was chosen, Oumuamua, a word from the Hawaiian language meaning scout, or messenger from afar. Publicly, the agency described it as a cigar-shaped object of unknown origin. Privately, notes between analysts used different language. Words like reflectivity anomaly, artificial albedo, unmodeled acceleration. And that's when the tone began to shift. Because when an object behaves like a comet, but looks like an asteroid and moves like neither, you start to wonder what you're really seeing. Within days, data channels tightened. Updates became curated, delayed. The official explanation, a natural interstellar fragment, was technically plausible, but not convincing. Behind closed doors, some asked a quieter question. What if Oumuamua wasn't a fragment at all? What if it was a design? A design drifting in silence through the dark between stars. And we almost missed it. The first rule of orbital mechanics is simple. Gravity writes every story. Everything that enters the sun's domain, from the smallest rock to the largest comet, plays by its rules. Oumuamua didn't. When researchers ran the simulation, the math fell apart. Its velocity, 87.3 kilometers per second, was too high for a captured object. Its arc through the ecliptic, hyperbolic, open-ended, meant it wasn't returning. Every known body in our system loops. This one was passing through. A cosmic one-way ticket. At first, that was thrilling. Then, the data started to argue back. The light curves, those rhythmic pulses of brightness, suggested a rotation pattern, but not a regular one. It tumbled chaotically, flashing sunlight like a mirror, and then, inexplicably, dimming into black. It wasn't round. It wasn't spherical. It wasn't even cigar-shaped, as early reports suggested. When reconstructed from brightness intervals, Oumuamua's form appeared. Flat. Maybe disc-like. Maybe sheet-like. An object with edges, not a fragment, but something that looked engineered. Then, the anomaly that changed everything. Science is supposed to be slow, deliberate, transparent. But nothing about Oumuamua followed those rules. The object was moving faster than models could update, and the world's data networks, from NASA to the European Space Agency, were suddenly scrambling to keep up. In Hawaii, the astronomers who first logged it barely slept. For them, this wasn't science fiction. It was raw observation. The numbers didn't care what you believed. Within days, the signal had rippled outward, from private mailing lists to public press wires. The phrase, first known interstellar object, hit global headlines on October 26th. By morning, it was everywhere. And that's when the story got away. Every outlet wanted a quote. Every scientist wanted caution. Every headline wanted wonder. The public saw discovery. The researchers saw danger, not of invasion, but of distortion. There's no evidence this object is artificial in nature. It's an unusual asteroid, and we're continuing to study its properties. The phrasing was careful, too careful, and scientists watching the briefing from their labs could feel it. A subtle tightening of language, as though the story had been rewritten mid-sentence. Internally, unease grew. Threads on private academic servers began to vanish. Colleagues reported login denials for datasets they had personally contributed, and key terms, light sail, reflectivity anomaly, non-gravitational acceleration, were quietly added to automated filters. One researcher typed a simple question into the internal chat. Are we being asked to stop talking about it? The message was deleted within minutes. Yet, for every dataset locked down, another leaked into the public domain. Forums lit up with mirrored copies of missing graphs. Amateur astronomers began cross-verifying data. And somewhere between official denial and open-source obsession, the truth blurred. What the world saw was chaos. Scientists versus skeptics. Skeptics versus believers. Each side accusing the other of hiding something. But inside the observatories, the tension was personal. One senior analyst described the moment they realized they'd never get full clearance to publish their findings. We weren't told to lie, they said. We were told to wait, which, in science, is the same thing others broke ranks quietly. A handful of physicists began releasing independent models. suggesting solar radiation pressure could explain the acceleration. If, and only if, the object were paper-thin. Their peers saw the implication instantly. Paper-thin, metallic, reflective, self-propelling. For the scientists, awe turned to isolation. Every new theory meant another media storm, another wave of ridicule or rumor. A few stopped responding to journalists altogether. One even left the project. But something else was happening too. The public was asking sharper questions about the missing data sets, the vanishing images, the retracted press bulletins. Why were simple orbital graphs suddenly under review? Why were timestamps mismatched between NASA and ESA logs? Why were journalists being told interviews were no longer authorized? Officially, it was bureaucracy. Unofficially, it looked like containment. And maybe that's exactly what it was. Not a cover-up, but a containment protocol. A way to slow the story until the world, or the evidence, could catch up. For those who had stared at Oumuamua's faint signal, the silence was deafening. They weren't chasing aliens. They were chasing truth. And truth had suddenly become classified. Sometimes, one astronomer wrote in a private memo, it's not the signal that scares them. It's what the silence implies. As it rounded the sun and began to exit, Oumuamua's speed increased. A small, steady acceleration, as if it were being pushed by an invisible hand. But no jets, no tail, no coma of evaporating gas. Nothing. The models broke again. Radiation pressure, sunlight itself, could account for it. If the object were thinner than a sheet of paper, yet tens of meters across, there's only one known design that fits those parameters. A solar sail. A propulsion concept tested in laboratories and low Earth orbit. A craft that rides photons like wind, sailing across the void without fuel. No natural rock behaves like that. No comet flattens into foil. So the question came quietly, off record, in private chats, inside encrypted servers. What if it's not natural? Some scientists dismissed it immediately. Coincidence, data noise. Others hesitated, because if this were a light sail, it wasn't ours. Then came the first odd disappearance. Spectral composition data, public for 2 days, vanished from NASA's open archive. The page redirected, the data set marked under revision. That happens sometimes. Calibration errors, misalignment, but usually corrections return within hours. This one never did. Was it caution or control? Maybe someone wanted to prevent panic. Maybe the numbers simply didn't add up yet. Or maybe they showed something that couldn't be easily explained. An albedo suggesting metal, not rock. A consistency impossible for a natural body. One internal report referred to the object as a candidate for artificial light pressure response. That phrasing, clinical, deniable, appeared only once, then vanished from subsequent drafts. Why remove it? Why lock the full motion data behind classified credentials? If Oumuamua was just an interstellar rock, there'd be no reason to restrict it. No reason to redact. No reason to hide behind language like unmodeled acceleration due to unknown factors. And yet, that's exactly what happened. Weeks later, official statements were cautious, sterile, likely natural, statistical outlier, unexplained but consistent with known physics. But off the record, one astronomer described it another way. It's as if something changed course to avoid us. Just slightly. If that's even partly true, Oumuamua wasn't just the first visitor. It was the first observer. By November, Oumuamua had already slipped beyond the range of our most powerful telescopes. The visitor was gone, but the debate had only just begun. 3 dominant theories emerged. Each tried to explain the same impossible behavior. Theory 1. Natural origin. The conservative camp held firm. Oumuamua, they said, was a fragment, a splinter from a shattered world flung into interstellar space by gravitational chaos eons ago. Its odd acceleration? A quirk of sublimating ice, or perhaps a new kind of cometary behavior we'd never observed this far from the sun. It was the simplest answer. And in science, the simplest answer usually wins. But the data didn't care about simplicity. Theory 2. Artificial design. A smaller boulder group proposed that Oumuamua might be engineered, a probe, a derelict, maybe even a fragment of something far larger. Its thinness and reflectivity matched what one might expect from a light sail. A propulsion system powered by starlight itself. If that were true, Oumuamua might not have been visiting by accident. It could have been sent, perhaps millions of years ago, by someone or something long vanished from the galaxy. Even those open to that idea admitted the odds were microscopic. But microscopic isn't zero. And then came the third theory, the one that changed the tone of every closed-door meeting. Theory 3. The phenomenon. Some physicists began to wonder, what if Oumuamua wasn't a thing at all? What if it was a reaction, an event, not an artifact? A few pointed to the data gaps, the strange discontinuities in light curves, the way its apparent shape kept changing with every new analysis. As if the object was responding not to sunlight, but to observation itself. Could it be a natural phenomenon, a kind of interstellar mirage, where charged dust and radiation align in a way that mimics solid form? Or something even stranger, a quantum-scale lensing effect, a fold in space-time that looked like an object but wasn't. One paper, never formally published, suggested that Oumuamua might represent a space-time scar, a residual signature left by the passage of something far larger and faster than we can measure. Not a visitor, but an afterimage. If that's true, Oumuamua wasn't a messenger, it was a footprint, a trace left by something that had already moved on, a wake in the cosmic ocean. The idea was dismissed publicly, too speculative, too abstract. But privately, some admitted it fit the data better than either the natural or artificial models. Because a phenomenon doesn't need propulsion. It doesn't need mass. It doesn't need to exist the way we think matter should. But that raises the question nobody wanted to ask aloud. If it wasn't an object, what created the signature? What passed through our solar system to leave a trail like that behind? Whether rock, relic, or ripple, Oumuamua forced humanity to confront a truth we've spent centuries avoiding. We still don't know what reality is made of. And if this was a phenomenon, something our instruments could see but not touch, then perhaps the reason NASA went quiet wasn't to hide the truth, but because they'd glimpsed something they couldn't yet define. Years later, the story refused to die. Not because of belief, but because of what the numbers wouldn't do. Align. Every few months, a new analysis appeared. Each one tried to explain away Oumuamua's impossible path, and each one quietly broke its own equations. It wasn't the absence of answers that haunted researchers. It was the pattern. A small residual acceleration, always in the same direction, always just beyond what sunlight could push. Some called it an instrument glitch. Others, a new class of interstellar debris. But when one team reconstructed the raw light data from independent observatories, they found something extraordinary. The brightness fluctuations didn't match a rotating object. They matched a pulse, a rise and fall of reflected energy at precise intervals. It could have been coincidence, or it could have been intent. The analysis stopped short of claiming communication, but in the margins of one paper an annotation appeared, handwritten. If the pattern is deliberate, then it's the faintest whisper ever recorded. The farther Oumuamua traveled, the more the signal decayed. By the time we looked again, it was gone, beyond the reach of our instruments, beyond the edge of memory. And maybe that was the point. Because the more we studied it, the clearer one truth became. We are terrible at living with the unknown. We rush to label, to categorize, to make the unthinkable fit our definitions. But what if Oumuamua was never meant to fit? What if it wasn't a message, but a mirror, showing us the limits of our own understanding? Maybe it wasn't technology. Maybe it wasn't rock or metal. Maybe it was reality itself reminding us how little we still know. In the years since, nothing quite like it has been seen again. But the instruments keep listening. Night after night, they watch the darkness, waiting for another impossible trajectory. Another data point that shouldn't exist, because science doesn't end with answers. It ends with better questions. Was Oumuamua an artifact? A phenomenon? Or proof that the universe still hides truths our equations can't hold? Whatever it was, it reminded us of something profound. That sometimes the universe speaks not in words or signals, but in absences. In the quiet between stars, where meaning is not given, only found.